Okay, so part 2 of notes, or continuation of notes. This is Tuesday. Again, first part of the test is tomorrow. It's a quick turnaround, but it's only 2 new equations, and they related to things that we already know. Right? It's applying integrals, which we know, to motion, which we know. So hopefully it's not too much of a new thing. All right, so example 3 here off the notes. The position of a particle is moving along the x-axis given by a twice differentiable function. Again, that just means it has 2 derivatives. So the velocity exists everywhere and the acceleration exists everywhere. X of 2 is less than 0. X prime of 2, oh wait a minute, X of 2 is the position. What's X prime of 2? Okay, slope, yes, but in motion specifically, the slope of position tells us velocity. And the second derivative is concavity, but in terms of motion, we would say that's the acceleration. So let's see here. Let's on the x-axis. Here's 0. X of 2 is less than 0. So my particle is over here somewhere. That's what this tells me. My position is less than 0. My velocity is less than 0. What does that tell me in terms of my picture? It's moving away from the origin because velocity is negative. You know what? I should be careful how I phrase that. Velocity is negative means I'm moving to the left, which in this case means I'm moving away from the origin. So what you said was right, but not directly flowing from this. So velocity is negative means velocity is to the left. Acceleration is negative. Okay, so that means it's trending toward the left. Let's look at our answer choices and see if we can make sense of that last acceleration thing. Don't really know how to use that yet. At time equals 2, the particle is moving toward or away from the origin. Okay, well the combination of those first 2 things, we're left of the origin, our velocity is leftward, so we're moving away from the origin. So the blue and red combine to make moving away. And then increasing speed, decreasing speed, that has to do with if V and A have the same sign. V and A, same sign. They're both negative, so that means speed is increasing. So it's answer D. Again, that's very much an AP question because you had to know a whole bunch of things to answer it correctly. And probably sketch a picture. Maybe you can do it without a picture, but very helpful picture. Number 4. Particle moves along the x-axis so that its acceleration is given by this. If the initial velocity, so I'm going to rewrite that as V of 0 is 6. At what time during 0 to 4 is the particle farthest to the right? Let's see. Okay, farthest to the right would be over here. That would be where velocity changes. I'm trying to figure out what to look for here. Velocity changes from positive to negative. That would be one way to say that. That would be farthest to the right. Or it turns around. So I need an expression for velocity. Position, velocity, acceleration. Remember, you take a derivative to move sort of down the chain. To move up the chain, you need to take an integral. So we have A, and I want to know velocity so I can know where it changes. Let's integrate A to get to V. So if I integrate A, I get the change in V. You know what? Let's do integrate A. So 2t minus 7 dt. And I'm going to get a plus C in there because I don't have two values to plug in. Like I don't have limits to think about. I mean, I got one of them, but I don't know which other one I should use. So I think I'm going to do the plus C part of this. So that'd be t squared minus 7t plus C. But I can solve for C because they told me what v of 0 is. So v of 0, so if I plug in 0, I get 0 squared minus 7 times 0 plus c, and that's supposed to equal 6. So c is 6. So there's my expression for velocity. I integrated acceleration to get to velocity, and then I used this initial condition, that's the fancy word for that, to figure out what c is. Now I have velocity, so now I can figure out where velocity changes from positive to negative. It's nice that they gave me a factorable velocity equation. So at t equals 1 and t equals 6, and I'm only looking for 0 to 4. So although I don't know that it's 1. Actually, this is sort of an endpoint, but it can't be 2 or 3. So it's down to 0, 1, or 4. Let's see. Maybe a sign chart to figure out what way this thing is moving. So it changes at 1. So v of 0 is 6, so it's positive. And then after that it's negative. So I mean, I didn't test anything. I just know it alternates because there wasn't any double roots. V of 0 is 6, so it's positive over here. So until time 1, it's positive velocity, it's moving to the right. At t equals 1, it turns around and starts having a negative velocity. So that means at t equals 1 is when it's farthest to the right. That was a tricky one. Again, you had to know how to navigate between position, velocity, acceleration, but not just that, because you had to figure out exactly what the velocity was and then know what you were looking for once you had the velocity, when it changed from positive to negative. Number 5, calculator question. Oh, put my calculator up. See how far I can get without it. A particle moves along the y-axis so that its velocity is given by this. At time equals 2, the position is negative 2. What is the position of the particle at time 4? Okay, so position, velocity, acceleration. Take a derivative to go this way, take an integral to go that way. It gave me velocity, and I'm looking for position, so I need to integrate velocity to get back to position. Now, on the last one, I had to integrate by hand, and I didn't know limits. This one, I hope, I've got a calculator, which means I can do this in the calculator, but that also means I need limits on there. So this would be s of something minus s of something else. What are the somethings? What should the boundaries be for this? What should my times be? Pardon? 2 and 4. At time 2, y is equal to negative 2, so we'll start at 2. And we want to know about 4, so we'll go to 4. So s of 4 minus s of 2. Because we know s of 2 is negative 2. So I need to put that in the calculator, and then probably one of those is the answer. probably the answer choice, one of the answer choices is just that, but then I need to add 2. Which makes me, I'm going to guess before I do this, I'm going to guess that my answer choice is D, because D is 2 more than this, so I'm guessing that C is this integral, and if I add 2 to it, I get D. I don't know. Let's plug them in and find out. Let's see, so math 9, 2 to 4. Yesterday I used Y1 a lot, the vars thing. I can do that here, but I don't need that equation for anything else. I don't need to graph it. I don't need anything. So rather than doing y equals and y1, I'm just going to type it in right here. Again, if you want to put it in y1 and then do the integral of y1, that's fine. Uh-oh. What did I do wrong? Because I think I need to add 2 to that. At time equals 2, the position of the particle is negative 2. What is the position of the particle at t equals 4? Oh, it's a double negative. That's why you do the math rather than... Let's go with his guesses. So this would be s of 4 minus negative 2. And so I need to subtract 2 from the answer I got. So I was right that this thing is one of the answer choices. I was messed up on my signs over there. So again, the difference between number 4 and number 5, we integrated to get to the prior step, to back up a step. On 4, we had to plug in a number to figure out what C is, so that we could do something with an equation. On 5, this was a definite integral. We knew boundaries, we had boundaries, and we could get a definite answer. Number 6, particle moves along the x-axis so that its position, not xvt, xva. Again, I don't know that this is really even necessary for this problem, but this is how I think of it. Take a derivative, move down the steps, take an antiderivative to move back up. So it's given me position. What is the velocity? So right away I know I'm going to need to take a derivative to get velocity. At the first instance, the particle is at the origin. Okay, well it's at the origin when x equals 0. So let's put 0 in for x. So where is the cosine? It doesn't say we have a yeah, well, this has got to be a calculator question based on those answer choices. I think I would probably do this in the calculator, just because your pre-cal knowledge might be a little bit rusty. So let's just let the calculator do the heavy work here. Cosine of the square root. And I want to know where that's 0. It's probably going to be an oscillating function because of the cosine. Alright, my scale isn't the greatest, but the first time it hits 0 is right there. Let's see. Change it up a little bit so you can see it better. Okay, so that's the time I want. So second calc, 0, left bound, right bound, guess. So that happens at 2.467. Kind of surprised that's not an answer choice. And since I'm using this answer later, probably best to carry some more decimals. Although those answers are all sufficiently far apart that I'm not going to be worried about accuracy. So velocity. Well, velocity is the x dt at t equals that thing. So, let's just find it on the graph. Like, you can go back to the main screen and do derivative, but you can also just do it on the graph. dy dx at 2.4674011 negative 0.38. Yes, sir.
How do you do this in that step?
Finding a derivative on the graph.
Yeah.
So when you're on the graph and you want to do something on the graph, almost all the options are second calc. Because that's where, like, we hardly ever do value, but if you wanted to plug something in on the graph, you do value. 0, that's where you're hunting for where it crosses the x-axis. You can use it to find a minimum or a maximum. And then those at the bottom, you can find the slope, or you can even do an integral. Reminder that if you do the integral, you need to give the lower and upper limit. So let's say we went from 1 to, here we go, to 4. The fun thing about doing an integral on the graph is that it shows you the area, so it kind of reminds you, hey, this is what we just found. Not necessary for this problem. That doesn't even have any meaning for this problem. But to answer your question, Ian, if you want to do something on the graph, second calc is probably your go-to spot. And then if you make it that far, then you remember, okay, it's there. Again, you didn't have to do it that way. You could go Math 8 out here and take the derivative of y1 at 2.4674011 and get the same thing. So some people always do it on the graph, other people will never do it on the graph. Either one is fine. Number 7, particle moves along the x-axis so that its velocity, again, I don't know, maybe it's overkill to write this every time, maybe it's helpful. This little picture, its velocity so I already can tell if I need a position, I'll antiderivative. If I need an acceleration, I'll take a derivative. At t equals 3, the position of the particle is 5. Find the position. So I'm going to have to integrate of the particle at 2. So let's integrate v. And this time I have two t values, so we'll just go from 2 to 3. So that's s of 3 minus s of 2. Or we're using x, so either one. And this one didn't say calculator or no calculator. You can do this without a calculator. You just have to FOIL it out and then do the antiderivative by hand. So let's use the calculator. So math 9. Times x minus 1 times x minus 3 with respect to x. Okay, so that antiderivative is negative 2. Let's see if I can not mess this one up. S of 3 is what we're looking for. No. S of 3 is 5. S of 2 is what we're looking for. So let's move things around. S of 2 then is 5 plus 2 is 7. Okay, again, the big thing, maybe this is there's the notes in one picture for the test. Position, velocity, acceleration. To move down, you take a derivative. To move up, you take an antiderivative. If you're taking an antiderivative, then you got to be careful about limits. You need two things. If you're taking a derivative, you usually just need one thing because you want the slope at a point. All right, in just a moment, I'll answer some questions from the worksheet.